please join me in welcoming our first keynote speaker, Michael, for his opening keynote, Brevis, the infinite compute layer for everything.
First of all, welcome everyone here, and really glad to see you all here this afternoon. Today, I'm going to talk about Brevis, what we building as what we call the infinite compute layer for Web3. What it actually is a smart ZK verifiable computing platform that you can use to do a lot of the cool things that I'm going to talk about. Let me just kind of state the problem and the challenge we're trying to solve today. So blockchains themselves are often advertised as world computers, but if you really think about it, they're incredibly slow and also expensive computers. Now, you may think that, wait, so it cannot be the case, right? So we have done so much in the last couple of years, in the last 10 years really, on scaling, layer 1 blockchains in general, we should be able to handle pretty much any kind of computation on layer 1. Well, unfortunately, that is not the case. Let me give you a very, very simple example here. You guys probably all used the centralized exchanges in the past, and you probably all have seen this kind of a very simple feature where if you traded a lot this month, then you get a fee discount in the next month. This is a great feature. It gives the exchange great user retention and also boosts the revenue bottom line. However, if you look at the entire DEX space today, like Uniswap, until very, very recently, none of them has this feature. It is not that they don't want this, because they know this works. This, boosts the revenue for the LP, it boosts the revenue for the entire protocol. But the real reason behind this is that building this kind of feature on chain directly to calculate what is the user trading volume, let's say in the last 30 days for only just a 10,000 trade, will bankrupt you in gas fee. And that's the fundamental reason that why we cannot have even this kind of a very simple user experience customization feature that should be available everywhere in the decentralized application space. Now, what is the fundamental reason for this? Well, it is actually rooted in how blockchain works fundamentally. So basically, you're running computation and a bunch of nodes is trying to agree with each other. Right, so today the consensus is built on the simplest form of computing. Let's say you have a 2-node blockchain. Alice is trying to calculate the result of the multiplication equation. She spent the computation power. Now she wants to convince Bob the result of the computation is such and such. So what Bob can do here today is just to run the entire computation again. Right now, we have this very, very simple way to do it. It's to do recomputation as a way to do verification. And this is how you can achieve consensus in a decentralized network. Or if you look at Ethereum, for example, Ethereum layer 1 has close to 1 million nodes. Now, what this means is that a simple computation like swap from token A to token B on a single node is going to be actually replicated 1 million times across all of these nodes in our network. People are going to do this computation again and again and again. This is why, if you look at the blockchain computation cost today, fundamentally it is still about 1 million times more expensive than the same kind of computation you can run on AWS. So we need to solve this, right? So we didn't have a good solution, but with the recent development of something called verifiable computing, now we have a solution. In this new paradigm of verifiable computing, you have different roles in the entire computation process. You have someone called a prover and then someone called a verifier. So for this prover, Alice, she's not only just doing the computation itself, but also generates something called a zero-knowledge proof. So this zero-knowledge proof is a very magical thing that you can use, and Alice can send this proof to anyone. The verifier here can just run a very, very simple, low-cost, low-latency verification process to say, oh yeah, if you give me this magical proof, I can be sure that the result of the computation is indeed the result you're telling me. Now, using a very, very simple example of multiplication equation here, in reality, and a very good benefit of the ZK proving is that no matter how complex the original computation is, even if it's let's say a large language model inference computation, the kind of proof you generate is almost always constant size and takes a constant and very low latency and very low cost to verify. So that's kind of the true magical thing about ZK. Now you have a way to actually decouple the computation process from the verification process. Remember that we talked about the first generation of consensus protocols that everyone do the same computation, but now you have a chance to have one node that does the computation and the rest of the network just do the verification itself. As you can see, the trick here, the blue bar, which is like the cost you need to spend on generating the proof, need to be smaller than the replicated computing cost. Until 2 years ago, this blue bar thing is actually going to be 1,000,000 times larger than the orange bar. However, with the rapid development of ZK proving technology, now we're just like within 100 times to 1,000 times larger than the original computation. Now, with this new development, this new paradigm of verifiable computing becomes a very tangible solution for the fundamental issue of blockchain scalability. So why is this important? This is important because, you can, empower a lot of more kind of different application use cases in blockchain, in AI, and in Web 2, all using this new kind of verifiable computing paradigm. We built this magic box that allows you to offload some very complex and data-heavy computation away from blockchain that blockchain cannot handle into this magic box. And Brevis is going to generate a ZK proof of the computation and send it back to the blockchain, so the blockchain itself can verify the proof easily as if the entire computation happened on-chain directly. So Brevis is not theoretical. We have integrated and supported numerous different applications, help them to, do reward distribution, help them to do grow TVL by empower new features that were not possible before, including MetaMask, PancakeSwap, Uniswap, Open Eden, Euro, all the names that like in different sectors, liquidity staking, lending, perp Dexes, and so many. Let me just go through a few that I think is kind of interesting. One category of use case that we do is something called intention DeFi. That is customized user experiences based on their user profile. So for example, we work with PancakeSwap to launch this kind of a new feature that allows users to generate a ZK proof of their historical trading volume and get fee discount on the fly. We did an A/B testing side by side, same pool, one with this feature, one without. This pool gives the LP 92% higher yield. And now they're powering their entire kind of a list of different pools using our technology and moving kind of to every pool into this as well. This kind of intelligent DeFi feature, it tells you that you can customize user experiences and customize kind of protocol features based on user profile, based on market condition. But you can also build your entire application in a verifiable domain. For example, we are working with one of the world's leading Dexes, perp Dexes, to actually convert their entire matching engine in ZK execution environment, so that you can actually have the same level of user experiences of a centralized exchange, but at the same time with the same level of security of the Ethereum layer 1, and with added benefit of privacy that is all powered by Brevis. And speaking of privacy, we have launched this very interesting and fun kind of a feature with Keynote that is allow you to essentially generate a ZK proof, a privacy preserving ZK proof that you are actually a holder of certain kind of tokens, with a certain amount, and you can associate this proof with your social profile without revealing your wallet address. And then, it gives you some boost when you're yapping about the project on Title platform. And it's actually initially used by us, but it's actually going to be adopted by a lot more projects that is launching on Keynote as well. Finally, I want to kind of talk about a reward distribution uses that we did with different kind of RWA platforms that allows you to essentially say, okay, I launched a stable token. The next thing I need to do is to essentially get adoption and distribute the reward. We built this kind of a new continuous protocol incentivization mechanism that allows users to generate a ZK proof for their usages in different protocols for the stable token, and use that as a way to allow users to directly claim the reward from the pool. This kind of a new reward distribution mechanism is much more transparent, secure, and at the same time compliant than a centralized system that can provide. And recently, we have been powering Linea's Linea Ignition program for helping Linea's chain growth process to also similarly allow users to generate ZK proof to let them claim the reward. And we also work with MetaMask card as well. My prediction is that in 10 years, 99% of computation for blockchain application is going to happen in an off-chain verifiable fashion. And, hopefully verified by ZK proof and Brevis. So I talked about Brevis is actually widely adopted by so many different use cases and applications, but what actually is inside the box? 3 pieces of things. So in the center, we have something called a Pico zkVM. What it is a RISC-V ISA-based kind of general purpose ZK virtual machine that allows you to essentially generate kind of a computation proof for literally any kind of program you want to run. The biggest difference between kind of our solution with like customized circuit solution is that it is a VM. So you can actually write your entire kind of a business logic or programming, high-level programming languages instead of this very complex constraint system that you need to kind of understand a lot about ZK. Basically, for example, we have a complete Rust toolchain. You can just write your program in Rust. Now, this actually matters a lot because now you have this new way to run consensus. Because let's say we have like an Ethereum client called RIS that you can basically say, okay, now I'm going to have a node that is packing and producing the execution result of this block with a bunch of transactions. And then I'm also going to generate the ZK proof of the block execution. And then instead of letting everyone else do the computation, I can just send a proof to all of them and let all these guys to verify the proof easily with extremely low cost. The important thing here, however, is that you need to generate a proof fast enough. You need to have a fast enough kind of virtual machine to actually do this. This is what we did is we launched something called Pico Prism that allows you to essentially generate most of the Ethereum proofs under like 10 seconds. And, this really kind of enables the next generation of kind of Ethereum scaling. One kind of a particular thing I want to highlight here is that there's this initiative from EF called easeproof.org. This is kind of a layer 2 be the equivalent of zkVMs. This is going to be a centerpiece of like, the center of a lot of things that is happening in the future. So Pico itself is like extremely performant, but there is always this kind of a trade-off between generality and also performance because it is a very general kind of system you can write any software on. We know that if you use some specialized circuit that is heavily optimized, you can get extremely high performance, but you kind of need to write circuit for every different kind of use cases. Where we as a Brevis want to operate on is this kind of a sweet spot of the trade-off plane that you can get the better of the both world. What do we do here? Well, modularity to the rescue. We treat Pico as the glue, and then we introduce this kind of a modularity or modular architecture where you can plug in different coprocessors as a specialized circuit and a specialized system that handles these kind of a commonly seen use cases very well. So we have many different kind of coprocessors on the application level. And one of them I want to highlight is something called on-chain ZK data coprocessor that allows you to generate proof of any kind of a historical on-chain data such as events, transactions, and user state. This kind of a coprocessor allows you to further kind of improve the performance for these kind of applications that involve this kind of proof and data need by another 2 orders of magnitude. Many of our application kind of use cases involve on-chain historical data traces, and this is why we are the only kind of a verifiable computing platform that has footprint in all of these spaces rather than just like the blockchain and the execution proving. So it's not just the underlying kind of a low-level execution proving that we work on, but all these different kind of application scenarios as well. So finally, as you can see that you have so many kind of different application scenarios that all need verifiable computing. Then you have different application need and different kind of a system that is optimized for different use cases. Well, how do you kind of all organize them together? Well, we definitely don't want to be the same single party runs proof all the time. Therefore, we very recently introduced the Brevis ProverNet that allows you to use something called a truthful online double auction, which is a very novel kind of auction mechanism to match the user demand to the supply of compute in an extremely efficient and truthful way. This is like where we kind of also introduced our Brev token as well as a utility token to power this entire system to be an open and decentralized proving network. So yeah, with that, this just want to kind of give you guys an introduction of verifiable computing and what we're doing at Brevis to power the future of the entire blockchain application space. Thank you.